So, of course, basic question natin and students natin, what's edge computing or the edge? Basically, it's a distributed paradigm. No? Na yung compute is happening and yung storage of data, no? Nandun siya as close to the device and application or dun sa component na nagko-collect or nag-generate ng data. It's pushed to the edge, no? Unlike sa cloud, centralized. Advantages nito, of course, better control over data, reduce cost to a degree, depende on how you would look at it. You would have faster insights and enable streamlined operations. No? You'll see it in a bit. So, this is the example ng isang edge computing deployment. Oops. Yan. Wherein you have your own cloud or data center pa rin to begin with. It's still doing the processing. But you are allowing yung mga edge devices nyo or IoT to that actually collects and gets data to process this data and maybe use it for their own use, and then eventually yung mga pre-processed data now would be sent eventually to the cloud. Some would require an intermediary for basic analytics or for real-time processing, pero as close to the source as possible. And then you have some caching, buffering optimization, and some machine-to-machine communication. Granted, this is not new. This is similar to content distribution networks that was developed in the 1990s. So at this time, it's 30 years old technology. No? But around 2000s, the CDNs basically naging edge servers sila for the mga earlier commercial versions ng mga edge computing platform. So his view ng CDNs ni Hostinger, where you have a user, yun yung mga tao on the map, that requires, let's say, a file from an origin server. But what the topology does pag naka-content delivery network ka is, okay, sample, Microsoft update or Apple update na recently kaka-release lang yung iOS 17. You ask the server yung mobile device mo, parang, meron bang update? Okay, origin server. And sabi ni origin server, yes, merong iOS 17 update, but don't download sa akin. Meron siya nun, but don't download sa akin. I-redirect ka to edge server that is close to your home network. And most likely, it's hosted sa ISP mo. Okay? Benefit is, well, let's say Apple, they have millions of users, I would say baka umabot pa sa billions, but baka hindi pa. If all of those would be asking their servers na mabubugbog si Apple infrastructure, so they subscribe to content delivery networks like Hostinger or Akamai to host their updates and bring it as close to the user as possible. So here they are trying to solve the number of connections and bandwidth and latency issue. Kasi instead of us, let's say sa Philippines, going directly to Apple US servers, which would be high latency and high cost of bandwidth. And one of the key objectives of Apple is to give you the update and disconnect you immediately from the network para hindi mo i-hog yung resource. And if you're using low bandwidth, high latency links, you're gonna be there for quite a long time. But if you're downloading data to an ISP, let's say ako naka PLDT fiber, and PLDT has a caching server or a content delivery server for Apple, or maybe not Apple directly, pwedeng hosted ni Akamai, then Akamai is sharing that platform across multiple companies, Apple, Microsoft, Google, it's gonna be there. I won't need to go directly to Apple. I'm just gonna be redirected to, sabi ni Apple, okay, sa Philippines ka, PLDT ka, based on my IP address. Sabi ni Apple, merong cache server, content delivery server, si PLDT. Doon ka kumonect, and doon ka kumonect ng updates. So, me downloading a 4 gig update, di ba? If I do it directly kay Apple, might take me 8 hours. Kay PLDT, it's gonna take me 5 minutes. Kasi again, high capacity, low latency, delivered agad sa device ko. So that's the objective, no? Make the computing and the resource, no, as close to the device as possible, making the network more optimized. Um, so, problem, di ba? From cloud computing na ayaw na natin ng server, sinipa natin yung mga server sa environment, you could see other organizations now, parang yung networks nila, it's just access network, no? And then direct to the internet, and then they access their servers sa cloud, no? So, all you need is in the cloud. No problem, it does work, but they are encountering issues for some use case, or a lot of use case actually, hindi lang some. They realized that bandwidth is expensive, no? Even especially sa atin, sa Philippines, no? Um, Aside from that, wala tayong major cloud data center within the Philippines. Our nearest one na AWS would be in Singapore. That means latency. No? To connect via submarine cables, there's going to be latency. So what if you're running a critical application, no? Na kailangan na real-time processing, hint, Open RAN, that might not work. No? So you need some processing power near yung mga compute nodes mo, or even on the compute node itself. Hence, yung last box dito sa cartoons natin, no? Parang okay, may brand new edge server ka, no? Dati pinush mo lahat sa cloud, although admittedly sa Philippines, no, medyo nandun pa tayo sa second stage na nagpo-push tayo sa cloud. That was sped up a bit, no, but a lot actually. During the pandemic, since kailangan na maraming compute power, this one, hindi mo kailangan magantay sa vendor to deliver you and set you up yung equipment. Diba? Basta may credit card ka, sign up kay AWS, kay Azure, kay GCP, you have your instance ready to serve, no? Yung purpose niya. And you have to only pay as you use. So, wala kang malaking capital expenditure. No? But as mentioned, no, hindi siya good enough for most use cases. So you need some help, no? Hence, edge computing. No? So again, data generating endpoints, this would send info, no, to a centralized platform, internal server, cloud-based server, either via LAN or WAN, or maybe both, no? And this centralized platform crunches and sends the data and output back to the endpoint, no? This is the issue with cloud computing, basically. And this becomes a problem, no? The more device you connect, basically it's a scalability issue, no? Would the server be able to handle it, no? Especially kung nasa cloud? While it is solvable via scaling, yung sa cloud, no? Meron tayong tinatawag na auto-scaling na if you configure your systems in a cluster, you could determine some threshold na, oops, pag 50% capacity na ako, mag-start na ako magdagdag ng nodes within my instances, no, in the cloud. Okay, to help out balance the required load, no. And then if let's say off-peak hours, walang gumagamit ng system, no, pwede ako mag-reduce, patayin ko yung mga machines na hindi kailangan and leave maybe a few bucks, no, to be able to handle weird services na off-peak dumadating. So that is solvable, no, with scalability and volume, no. What's not solvable would be latency with the cloud kasi it is far from the endpoint na nag-generate ng data. They would have to submit their data for processing on a typical cloud environment. And you cannot beat physics, no? Ultimately, we are limited with the speed of light. And as we know sa physics, speed of light has latency. Meron siyang ano ba yung formula? Equals mc squared. No, but c would be the speed of light, pero hindi yung hinahanap natin. But there is a time required, no, for a data to be transmitted from the Philippines, let's say, even to the nearest one, no, na data center sa Singapore. Maybe a few milliseconds, no, to reach that. So imagine you have thousands of devices na try to connect to your servers, nag-i-scale ka, nagmamahal yung cost mo, tapos high latency. And we'll discuss some use case na kung bakit hindi, yung sa challenges and limitation, bakit this is not solvable with the cloud, but edge computing would be coming to help.